Okay, so hello, welcome everybody. Today's Martin Audio presentation is on one of the Wavefront Precision series of loudspeakers. Today we are looking at WPS, the most recent in the Wavefront Precision loudspeaker range. My name is Robin Dibble. I am a product support engineer, so my day job is largely these days, especially sitting in front of a computer with acoustic prediction software, designing sound systems for venues, and with my colleagues Ben and Simon, who are both online with me today to answer your questions. Between us, or particularly Ben and Simon, we put together these presentations, and we also present training, usually around the world, but in these rather different times, mostly from our bedrooms at home, as I am today. So WPS forms part of our range of optimized line source loudspeaker systems using a principle called scalable resolution. This is something we'll go into in a little bit more detail later on, but it allows us to change the number of loudspeakers we connect to each amplifier channel whilst electronically optimizing them to give the best possible performance of sound system for your venue or space. So we're going to start by having a look at the loudspeakers themselves. Now, WPS is quite a box. There are 10 drive units packed into this little package, which is just 650 millimeters wide. Frequency response from 70 Hz to 18 kilohertz plus minus 3 dB with a peak SPL per box of 133 dB. Horizontal coverage is an extremely well controlled 100 degrees. We'll go into why it's so well controlled in a little while. And each box has a vertical coverage angle of 10 degrees. Obviously, ultimately, the coverage angle in the vertical plane is defined by the number of boxes you have, the setup, and by the software. Each box weighs 27 kilos, so it's very easy to handle. WPS uses this function called scalable resolution, which is a very advanced method of controlling the vertical directivity of your array. As I said, we're going to go into that in more detail a little bit later on. It's a 3-point rigging system, pre-selectable, so you can pre-select your angles while it's still in its touring frame before it goes up into the air. It uses our dedicated Icon multi-channel amplification, so the system is sold as a complete package with its power amplifiers. We do this because only our Icon amplifiers have the DSP power on board that's needed to achieve the optimization and also to guarantee you get the same sound quality wherever you are, wherever in the world you unpack this system and use it in the world. You use the Display 2.3 software to optimize the array and get the best performance from it. And to make life very easy in terms of amplifier channel allocation, it's a 3-way passive enclosure. So just a single amplifier channel is all that's needed to drive the box or quantity of boxes. Let's have a look at what's inside there. So at the top end, we have 4 1-inch exit compression drivers. These are mounted onto the horn flare via waveguides, so they sum couple properly at the high frequency domain to make them perform as a true line source. Now, the high frequency units actually cross over quite high by comparison to other loudspeaker systems. We use small, lightweight diaphragm high frequency drivers to get better high frequency extension and lower distortion. And the reason we can do that and not have to use large compression drivers is because we have these 4 4-inch mid-range drivers in close proximity to each other, also in the mouth of the horn flare. Below those, we have our low frequency section of 2 8-inch drive units. Now, these are compression loaded behind the horn flare that comprises the front of the box. So all in all, we have a very compact 3-way enclosure with 10 drive units in it, all of which are working in their optimum bandwidth. And the design of the box is such that it maintains exceptional horizontal pattern control. So with a conventional 8-inch 2-way line array cabinet, you tend to find that as you go up into the mid-band, the horizontal pattern control collapses due to interference between the 2 horizontally spaced 8-inch low frequency drivers. Because this is a 3-way box, we can cross over at a lower frequency before our horizontal pattern control collapses, meaning we maintain good pattern control right the way through the operating frequency range of the cabinet. This is the SXC118 subwoofer, now also available with full flying hardware as the SXCF118. This is a cardioid single 18-inch subwoofer with a frequency response down to 43 Hz. It has a peak SPL of 140 dB and a cardioid coverage pattern. This is achieved by having a second 14-inch driver in the back of the box. So this is an active cardioid. It uses 2 power amplifier channels to drive the box, but you can still parallel 2 boxes together, so amplifier channel count isn't really an issue. The 14-inch rear-facing driver means that we can achieve exceptional rear rejection, whilst also increasing the level of output of the subwoofer as against a single 18 at the front of the box, the important bit that's facing the audience. So on the left here, you can see the SX118. This is a conventional output pattern for pretty much any subwoofer. You can see it's more or less omnidirectional. We've got as much energy going out the back as we've got coming out of the front. This isn't much fun when you've got a line of subwoofers in front of a stage, because you get all that low frequency energy coming back onto the stage and polluting the sound that goes back into the microphones or causing feedback on your DJ's turntables. By using a cardioid subwoofer such as the SXC118, you can see this particular cardioid sub is achieving 21 dB of rejection at the back of the box, whilst that rear-facing 14 is also adding 2 dB of level to what comes out the front. So this is pretty unique, and the reason we can achieve this is because it's an actively driven cardioid, not a passive cardioid. So the key benefits of the Wavefront Precision series is the consistent coverage that's achieved throughout the audience space. So this isn't just a case of making it sound sweet and lovely where the front of house engineer is. It means that everybody in the audience gets that same sonic experience as the front of house engineer. There are no particular sweet spots, there are no particular dead spots. As long as the software is set up right and you've told it exactly what you want it to do, you'll get beautiful even coverage, same tonality to every member of your audience space. The display software means you have a reduced setup time for the array. There's a set and forget, it goes up in the air and you know it's going to be right first time. So let's have a look at how we can put a WPS system together. So there's a complete rigging package for the WPS. The box itself uses this 3-point captive rigging system that allows you to pre-select the angles while the array is still on the ground. There is the full spec touring flybar, which also allows you to ground stack the arrays and also fly subwoofers from the same frame. There is then a simplified installation flybar. You can see up there on the top right. Lower cost and lighter weight. This is ideal for permanent installation of the system. The flown subwoofer, the SXCF118 itself, has 4-point rigging, which locks in to the WPS grid T, the touring flybar up in the center. We then have the outriggers to keep the array stable when it's ground stacked. And there is a full touring cart available, which carries 4 WPS cabinets. So let's have a look at what's on the enclosure. So at the back, we have pocket handles, which may enable you to easily lift the back of the box and get it into place. Handles on the side as well for carrying. You have front floating links. So the front corner top mounting points are fully floating. So when you are trying to fly an array, for example, on uneven surfaces like outdoors, you haven't got to try and align one array on top of another array and all the fiddling about that involves to get the pins in place. Input connectors on the back of the box are the newer Nitrix STX type, so they are standard speak-on pattern, but they are the metal-cased high-grade touring connectors for good longevity. Here's the grid itself. So you can see at the front of the frame, bottom left on the picture, that's the front rigging point where your floating points from the array attach to. you have a second rigging point you can see across the bottom. So you can fly the array either to the front or the rear of this touring grid. When you put it to the rear of the grid, it means you have more up tilt available. When you attach it to the front of the grid, is the more standard situation, giving you the greatest degree of down tilt available. The front point and the rear, very rear points are also the mounting points for the SXCF118 when you're flying those beneath the grid. This is also the transition grid when you fly WPS below SXCF118s. 2 shackle points, front and rear, and you can fly from single point or dual point rigging with this frame. Total and maximum of 24 WPS go from this grid, 16 if you needed to reach BGVC1 status in countries like Germany, for example, and you can fly a maximum of 16 of the subwoofers from this frame too. If you're going to do a mixed array, then your maximum is going to be 3 subs and 9 array cabinets, or combinations in between the two. Installation grid, much simpler altogether. Front rigging pin straight onto the box, single T-bar shape. You can see the rear link pin there that drops down to connect to the back of the boxes. Nice and tidy, very simple, lower cost, low profile, absolutely perfect for installed arrays. The WPS cart is a very convenient way of touring the system. It allows you to very easily just lift the array straight out on a motor and drop it back in and pack it away at the end of a gig. Also, while it's in the frame, you can pre-select all your angles in the back of the boxes, and as you lift the array out of the frame, they all just fall into place, and you put a lock pin in at the rear of the box, each box, as it goes up into the air. So the touring grid, as we said, you can have 1 or 2 motor suspension. The software, if you're using single point hang, will tell you which hole across the top of the frame to use. You can see there are 21 single pickup points across the top of the frame there at the bottom right. So the software tells you which of those to use to get the correct angle, or of course, if you're using dual motor points, the software will tell you what angle the flying grid needs to be at to get the correct coverage from the array. Worth noting, you can see on the left-hand side there, the little blow-up bubble, that the link between the grid and the top corner of the first cabinet is the height that display uses to determine the height of the array. So it's not using the top height of the frame, but the top height of the top cabinet in the array. To ground stack WPS, we have this ground stack bar, which gives you either in this orientation aiming angles of from 0 flat to +5 degrees of up tilt, or used the other way up. It gives you down tilt aiming of -6 to -20 degrees. Again, the software gives you all the details that you need to know of which holes to pin the ground stack support bar into on the frame and also on the loudspeaker itself. Now, the outrigger bars will be used either directly onto the fly frame itself when it's used as the ground stack frame at the front to give stability. So as the array is tilting down, it gives it a bigger footprint so that the array isn't going to topple over. When you ground stack on top of the subs, you just move those ground stack bars to the bottom of the lowest sub to give you increased stability. When you're ground stacking, you have a maximum of 6 WPS cabinets on the frame. Okay, let's move on and take a look at the specific amplifier and electronics that drives this system. Now, remember that WP systems, all of them will only work with Icon amplifiers, so you can't substitute any other brands that you may already have or may be looking at. They exclusively work with the IK series of amplifiers. So the IK42 is the nominated power amplifier for WPS. It provides 4 channels of very high quality Class D amplification. Now these are stunning sounding amplifiers. The audio quality is quite exceptional, and have compared to any other product we've tried, the sonic quality is by far and away the best on the market today, we think. There's a total of 20,000 watts of output power available when you have 2 ohm loads on each channel, so that's 5,000 watts per channel at 2 ohms. The DSP is 96K, that reduces to 48K in FIR mode. Otherwise, the latency through the system would double, which would make for a lot of latency, which we really don't want to experience. Main sensing is entirely automatic. From 85 volts up to 240, it will look after itself. You have audio inputs in the form of 4 analog. You have 4 AES channels in, and 2 AES channels in, and 4 channels of Dante. The network control is all based on Ethernet, and we use our ViewNet software to monitor, control, and upload our files into these amplifiers. So on the front panel of the power amplifier, there's a bunch of buttons and some pretty flashing lights, and it's a good idea to know what they do. So firstly, the online light, which is at the top left-hand corner of the red box you can see around the panel. If that light is off, it means there's no network currently connected to the amplifier, no control network, that is. If it's flashing, it's trying to find an IP address from DHCP. Obviously, that won't happen if you're using fixed IP addressing. And if it's on, it means that it's connected to a network and it's talking to a computer that is running ViewNet. The AES3 light, fairly straightforwardly, it lights up when it's getting an AES3 source, or when one or more of the inputs in the amplifier is actually using and selected to an AES input source. The overlay light, this illuminates when there are active parameters within the amplifier which you can't access. So there are things happening inside the amplifier that have been uploaded that are not accessible from the front panel. So for example, the optimization parameters for a WP array. Finally, the Dante light, again, this lights up when you've got any of the input channels routed to a Dante input stream. Control of the amplifier, obviously fairly standard. The up and down buttons scroll through the different functions which appear on the LCD screen to the left-hand side. The enter button is what you use to confirm data entry as normal, and the input, utility, and output buttons allow you to navigate to the menus for each section including things like limiter settings, EQ parameters, that kind of thing, or utility, which gives you the basic housekeeping functions of the amplifier. So the 2 rotary controls, the select control selects which parameter you want to adjust. So for example, you can see here that the width is in a heavier type than frequency or gain. So that's because we've twisted the select knob. As it's gone across the screen, the function that you're going to be able to adjust with the adjust button is the one which is in the heavier type. So select to move across to get to the parameter, and adjust to change the value in that selected box. Then of course enter to confirm that you've got the right settings in there and you want it stored into the amplifier. The level meters on the front of the amplifier, we have 3 for our inputs, A, B, C, and D. The input clip and mute LED, that's the top LED on the left-hand side. Fairly obviously, if that input is muted from the control system, then that will show red. And also likewise, that will show red if you clip the input of the amplifier. Good luck if you've managed to do that. It doesn't clip to about plus 28 dBu. Input signal LEDs, the bottom signal LED present light lights at around about minus 40 dBu. Then you have minus 12 and 0, obviously, as you can see from the display. The clip LED indicates actually 1 dB below clip, so you've got a bit of forenotice that you might actually want to change your gain structure. Our output display, so again we have speaker over and amp over indicators, limiter which lights up to tell us that the threshold of any preset limiter within the amplifier has been reached. Obviously a bridge light speaks for itself. If the channels are bridged, that lights up. Output mute buttons at the bottom there, they light up when you've pressed them and the amplifier is muted. They will also flash if the amplifier is in a fault condition on any one of the channels. So if a fault condition exists on, say, channel 2, there's a short, then that mute button will be flashing away to let you know that there's a problem with that particular output. Again, we have output signal indicators that there's a signal present, and also sort of -6. And then our amp over indicator, which is clip, again, lights 1 dB below actual clip threshold, so you've got some idea of what's going on. Back panel, we have our 4 analog inputs with a link out, which is very convenient for patching through an amplifier rack. And we have our AES input, just the one AES input, so that's 2 channels of AES available to go into the amplifier. Our network ports, Dante primary and secondary with automatic fallover, all the usual stuff you'd expect from Dante. And there's also the Ethernet control port there for your control network talking to ViewNet. And on the far right-hand side of the amplifier panel, we have an auxiliary port. This is available for external control, so you can externally record different parameters, for example, different presets via a contact closure. It can also be used as fault indication out to a control system to let you know remotely if one of the amplifiers has gone into a fault condition. Mains connection is via the 30 amp PowerCon HC you can see at the bottom right-hand side. IK42 output connections, you can see that there are 4 speakons on the back, 1 for each channel, but speakons 1 and 3 also have their subsequent channel available on pin set 2. So for example, speakon 1 has output channel 1 on pins 1 positive and 1 negative, channel 2 on 2 positive and 2 negative. This makes life connecting loudspeaker systems very easy when they're biamped, or for example when you're driving the SXC subwoofers, because both channels are available on a single 4-core cable. You can buy the amplifiers as individual units, or we can supply them as a complete system rack, and you can see here the IK42 amp rack. Total of 12 amplifier channels in there. It will drive your WPS arrays and your subwoofers. You've got a total of 60,000 watts of output power in one 9U rack. You have an input panel on the back, input and output panels on the back of the box, 2 network switches. Connections on the back, there are 2 versions of the output distro. There's a UK version and a US version. So the UK Europe version uses standard C-form 32 amp 3-phase mains inlet connector. The US version uses a 3-phase twist lock Hubble connector. We then have our output patching, all of which is available on either NL8s or NL4s to suit your cabling requirements. The input panel on the back of the rack gives you analog audio inputs, 6 channels of analog audio in on the PA-Con connector. Linked into that, paralleled across, are 2 analog ins and link outs on XLR. We then have Dante primary and secondary ports, and we have our AES in and out. A nice, neat, tidy input panel for the rack. So let's have a look at how the system goes together. Input connection to each box is on the NL4 connectors. Pin 1 positive and 1 negative are the inputs, and 2 positive, 2 negative are linked through internally in the box. This is useful for when you're using, for example, 2-box resolution or multiple box resolutions. You can link one cabinet through to the next on alternate amplifier channels. So we think about our pin 1 positive and 1 negative would go directly to the drivers in this box. 2 positive and 2 negative from your 4-core cable are linked through. You can then use a pin rotator connector to connect into the next box down the array when you're using 1-box resolution. The SXC subwoofer, the SXC 118, and also applies to the flown version. 2 connectors, NL4 again. Pin set 1 is for the 18-inch and pin set 2 drives the 14. Parallel out allows you to connect 2 speakers together for each pair of channels of an IK42. So how does it go together in terms of amplifier connection? Well, what we're looking at here is the lowest resolution, 3-box resolution WPS system, and you can get up to 12 channels of amplifier of loudspeaker to 1 power amplifier. So very cost effective, and as you'll see later on, still with a great deal more control than a conventional line array will give you. So that's, for example, 2 6-box hangs with optimization on 1 power amplifier. Subwoofers, you can have a maximum of 4 on an IK42. That's how they connect up. So we have a 4-core cable coming out of our power amplifier straight into cabinet 1, linked across to cabinet 2. And there we have 4 cardioid subs running nice and tidily from 1 power amplifier. So a straightforward array, be it flown or stacked, has a bandwidth of 70 Hz to 18K. The presets for it that are uploaded into the amplifiers are defined simply in Display 2.3 software, and we use our IK42 amplifier. 100 degrees horizontal coverage, very well controlled, as we've already discussed. We can then add our subwoofers in multiple different configurations, so we can fly our subs above our array, obviously now extending our frequency response down to 34 Hz at -10 dB for the entire array. You can fly your array completely separately to your subs, with your subs ground stacked or in a broadside array at front of the stage. And you can stack your WPS directly above SXC F118s. We recommend a minimum of 1 SXC 118 per 4 WPS. Obviously, that's going to be entirely dependent on the amount of low frequency content there is in your program material. So let's have a look at this scalable resolution. What's it all about and what does it do for us? With the Wavefront precision system, you can connect with WPS 3, 2, or 1 box per amplifier channel. The fewer boxes you have per amplifier channel, or the more amplifier channels there are in the system, to look at it the other way around, then obviously you're going to get more pattern control from the system, because you have more DSP power, and also you're controlling smaller parts of the array individually rather than large chunks of an array individually. But as you'll see, even at the lowest 3-box resolution, you're going to get far better control across your audience than you will with any conventional array system. So let's have a look at what a standard array preset is going to do with frequency response through a venue. So as you can see here, we're looking at responses at the audience front row in red. Our mix engineer is sitting where the yellow line is. The back row of our audience is the green curve, and what we're looking at in blue is the amount of level that's present on the stage behind the PA. So this is a standard array preset in a WPS system. So it's what we call the emergency default preset, which simply gives a tonal balance without any optimization. You can see there's significant variance in not only sound pressure level, but also the shape of the frequency response in the 3 areas. So wherever you're standing, you're actually going to hear subjectively a different mix balance depending on which part of the frequency range is accentuated wherever you're standing. There's also an awful lot of noise on the stage. Now, not only does that mean we're going to might have some issues with gain before feedback, it also means that the sound of the PA, or the back of the PA, is coming back into the microphones, muddying up the mix and generally spoiling the amount of quality we can get from the system for everybody in the audience space. So let's split that up now and look at a 3-box optimization. So that's 6 boxes with in an array with them processed for 3 boxes at a time. So effectively using 2 amplifier channels to drive those 6 boxes. We now optimize electronically the performance of each of those groups of 3 to try and smooth that response out. And you can see that immediately, even at the lowest resolution, we have a significant improvement in the smoothness of response and SPL profile across the audience space. Now, normally with a conventional array, you wouldn't connect more than 3 channels to an amplifier channel or pair of channels anyway. So why not do the optimization? It improves things significantly for everybody in the room. And we're also already dropping the level on the stage, as you can see from the blue curve. Take that up a step to 2-box resolution, and as you'd expect, more processing, more amplifier channels, higher granularity, so we are getting more control and a more consistent response through the space. Finally, 1-box optimization, so we have 1 amplifier channel per cabinet, and you can see we have a level of smoothness through the room that's almost approaching what our top-end MLA systems are capable of, and our stage noise is significantly reduced, ensuring much cleaner mix, which means everybody, front of house engineer included, is having a far better time. So in real terms, that's what this system we've been talking about looks like. So at 3-box resolution, we have 3 cabinets parallel together off 1 channel of an IK42. So we've either got a 12-box hang off 1 amplifier, or we've got 2 6-box hangs powered from 1 amplifier at our lowest level of resolution. Moving through to the highest, then we're connecting each individual box to 1 power amplifier channel. So our amplifier channel count goes out, so obviously our costs are going to go up, but you've already seen the significant advantages there are to be had at 1-box resolution. There's a whole suite of accessories available to go with your Wavefront Precision system. So there's a full package of cables available, including multi-cores to go up to the arrays, breakouts, looms, the complete package. So all of which is available. You can specify from our price list, or your dealer or distributor can put the complete package together for you. So this example here, you can see we're using 16 boxes of WPS, or 2 hangs of 8, with flown subs, uses a total of 24 amplifier channels, or 2 complete IK amp racks. Complete deployment, there's no amplifier channel spare here, but we do have enough amplifier channels to also drive our front fill loudspeakers. In this case, it's DD6s. So at 2-box resolution, we can drive a complete stereo 8-box hang from 1 IK amp rack with 2-box resolution and also power our subwoofers. So a very neat compact system with exceptional control throughout our audience space, which will fit in a small van without too much kit to carry around. And again, all the cables you can see there listed, everything you need to put your package together. The advantage of a scalable resolution system is that you can better design your system, be that a permanent installation or for a touring system, to suit the budgets that are available. And over time, you can improve the consistency of coverage by adding more amplifiers as the capital becomes available. From an install, this means your first pass at the install can specify the right number of boxes to make sure you get the correct audience coverage, but start at the lower cost. For example, 3-box resolution, and then come back to the venue a year later, add some more amplifiers, improve everything by moving that to 2-box or 1-box. From a rental point of view, it means that the same loudspeaker arrays can go out whether you have a higher or lower budget tour. You just vary the number of amplifier racks that you send out on the job, depending on the budget that's available for the tour. It also provides a great flexibility with the system. So for example, you may decide that you want higher resolution on your main PA, but your delays don't need to have quite so much control, so they can be run at a lower resolution. So let's have a brief look at the software that controls this system. Display 2.3 is the software we're talking about, and there are webinars available on the website. We also conduct them live regularly, so keep an eye on your email inbox and social media for when those live webinars come up. But as I say, there are recorded versions of how to use Display 2.3 and what it does for you in the training section of the Martin Audio website. So it's proprietary software, it's completely unique and uses unique algorithms developed by Martin Audio to optimize an array in its vertical coverage plane. It gives us a file which we send to our power amplifiers via ViewNet, which makes the array behave in the way we want it to for our room. There are 4 easy steps to the optimization. This is just a very quick overview. Firstly, we define a slice in the software. So we're looking at a vertical cut through the venue and define where our audience is in front of the array and the basic room shape. Next, we tell the system where the audience area is. Those are the green dots you can see at the bottom of the shell. Where our audience isn't, which are the red dots, and also the blue, which is where our hard avoid is. So the difference between these is our audience area. The green area is where the software is going to optimize the coverage for maximum consistency and evenness of tonality. The red areas, the software is going to aim for a 20 dB level attenuation against that in the audience area. And the blue, the hard avoid, this is the unique Martin Audio feature, and here the software is going to aim to adapt the system so that simultaneously to the 2 other things we've mentioned, it's going to aim to achieve 30 dB of attenuation in that region. Now the hard avoid can be placed on the stage, which means you get this reduced level from the back of the PA, so we get a cleaner mix. Or it may be that that is going to be used somewhere like on a highly reflective black wall, which is giving you reflections into your audience and destroying the sound quality. Next, the software will calculate the angles that are needed between each box and also the array overall tilt angles. Now, this isn't a purely geometric model. This is based on an acoustic model. So it's optimizing the shape of the array to get best possible coverage in the audience space, even before we do the electronic optimization. Last step, it calculates the filters themselves. So at this point, it's now going to generate a bunch of filter settings using FIR filtering, phase, delay, and level relationship alterations between each cabinet in the array, in this case, as it's 1 box resolution, to achieve its goals of getting as close as possible to uniform response across the audience space whilst keeping sound away from the areas where we don't want it to go. So that's 4 steps. Venue entry, tell it what you wanted to do, and then it tells you what you need to know, how to hang the array, and also gives you the files that you need to upload into your power amplifiers. So every time you deploy a Wavefront precision system, you need to optimize it to the room. So each time you go into a venue, quick measurement of the room, put the data into display, and then it gives you the answers that you need and optimizes that PA for the room that you're working in. It gives you the best possible array shape for the room as a starting point and ends up delivering a very even frequency response throughout your audience space. You can control the SPL drop-off, so you can, from the front to the back of the audience, you can change the SPL rate of fall-off. And one really unique feature is you can create multiple optimizations for any audience conditions. So for example, if you're in a theater with a balcony, you can have your audience area covering the entire room. That defines your array shape. But you can then go back, turn your balcony area into a non-audience region, re-optimize just electronically, keeping the same array shape, and the software will drop the level that's on the balcony. So it's very useful, for example, if you're doing a run in a venue and some days the balcony hasn't been sold, there's no people up there, so you can reduce the sound energy in that region so you don't get the sound echoing about up in the balcony and coming back into where you do have an audience. Each optimization can then be stored and recalled from the amplifiers via the ViewNet software. The ViewNet software itself, again, you will find webinars up on the website which go into ViewNet in great detail of exactly how it works and how to upload the files. It's a software that controls all of our electronic products, but in particular in this context allows you to update and upload rather the optimizations from display into your power amplifiers. It does all your housekeeping work, so this gives you access to all your EQ, delay settings, all that kind of stuff. Allows you to gang across the network different EQs in different amplifiers. It also allows you to do firmware updates to the power amplifiers. On which subject we will regularly send out emails or social media or whatever to users of our systems to let you know when there are firmware updates available, and we always recommend keeping your system up to date with the latest firmware advances.